In this section, we'll be looking at indefinite integrals. Now, an indefinite integral would be an integral where we do not have our limits going from a to b. We don't have numbers here. Okay, so this right here would be a definite integral. And so this one's going to give us a specific number, but this one, an indefinite integral, is going to give us a general antiderivative. So we've actually done some of these before. These are where we take the antiderivative and add c. So if I want to work out this indefinite integral, then I would just take an antiderivative. X cubed times 1/3. The antiderivative sign would be negative cosine, so that's going to become plus cosine of x, and then be sure to add a plus c on the end. Now, if we want to double check these and make sure they're right, we can go back and take a derivative of that, 3 times 1/3, and subtract our exponent by 1, so x squared. Derivative of cosine is negative sine of x. And then the c becomes 0, so we know that we've done this correctly because when we take the derivative, we get the integrand. Now, if we're asked to verify an antiderivative formula, what they're giving us here is an indefinite integral. They say this is the solution to that, or the antiderivative, and we want to check it. So to check it, we'll just take this part and take the derivative to see if we get what's inside over here. Now, since this is an absolute value problem, I'm going to need to think about this in two parts. I could think about using positive values, or I could think about using the negative values. I want to take the derivative, so d du of whatever we have here, absolute value of u plus c. Now the first thing, since these are positive numbers here, I can drop my absolute value sign, leaving me with just ln of u plus c. I can take the derivative then. The derivative of ln u would be 1 over u, and then c would be 0. So we notice that we're getting this inside part again, and so this side checks out. So let's also check it for the negative side. We're taking the derivative, again, of the same thing, absolute value of u plus c. So we're showing that we're starting with that. And then now, because we are on the negative side, we'll do a substitution for our absolute value, where we'll put a negative u inside of here. That will change it to a positive number, and then that will give us, when we take our derivative of that, we'll need to use the chain rule. 1 over negative u, okay, so 1 over whatever's inside, times the derivative of whatever's inside. The derivative of negative u would be negative 1. And then again, plus 0 there for that c. The negative and the negative cancel out and give me 1 over u. So in both cases, I'm getting 1 over u, so we verified that this is the correct antiderivative of 1 over u. This next part we're going to look at is when we start mixing variables in our indefinite integrals. Like if I have f of u du, that's going to be different from f of u dx. And it's one of the reasons why it's so important to include this with your integral, because we need to know what variable we're dealing with when we take the integral. And substitution is going to matter here when we do things. So we need to make sure when we take an antiderivative that we're dealing with x with dx, u with du. So if I have a problem like this, notice that f of x is defined in terms of x, but we also know what u is in terms of x, and in some of these we're going to need to substitute and do our integration in the correct order. And one thing we could look at, like with this du here, we could think of that du as being the derivative of u. So du would be equal to, since this is x squared, be 2x dx. And that's going to give us a couple different ways that we could do some of these problems. But let's start with the first one, f of x dx. This is simply plugging in our formula. F of x is x cubed plus 1 dx. Now since this is in terms of x and we're taking the integral with respect to x, we can just do it normally. We raise our exponent, 1 becomes x, and then we remember to do plus c. So that one's finished. Now for the second one, we have a u here, and it is du. So when I substitute this in, notice f of u would just be this here, except I'm plugging in a u instead. U cubed plus 1 du. And so that's also going to give me an antiderivative that looks similar, u to the fourth plus u plus c. The difference being that we want our answer in terms of x, so we're going to do our substitution now. And so this will become 1/4. Since u is equal to x squared, then that would mean that we have x to the 8th, because x squared to the 4th. U is x squared, and we still have plus a constant here. So notice this ends up looking a lot different than when we had f of x dx. For the next one, we have f of u du. So we're going to start by doing the substitution here. We'll have u cubed plus 1. But notice this is dx, and so we can't proceed yet because our variables don't agree. We'll need to do the substitution now. And so plugging in x squared, that will give us x to the 6th plus 1 dx. Okay, so in this one we integrate first, then substitute. This one we're going to need to substitute first. When we take the antiderivative, that's going to give me 1/7 x to the 7th, and then still plus x and plus a constant. But that looks very different from what we had when we did the u du and substitute later. And so we have to be careful to make sure that our variables agree on these. Now you'll notice I didn't do anything with this du is equal to 2x dx yet. Remember again, that came from looking at how u is related to x. Now where that could come into play is if I chose to do a different kind of substitution here. Like let's say with this one, we chose to do this with respect to x instead. We need to do some substitutions. I could do that if I plug in everything. So if I start by plugging in x squared for u, that would give me x to the 6th plus 1. But this is du, and I would need to have dx. So to do that substitution for du, I would need to plug in 2x dx. That would make this integral here equal to, if I go ahead and multiply that 2x in here, 2x to the 7th plus 2x dx. And if I take my antiderivative here, my variables now agree. Raising this power will give me x to the 8th, which would make this 1/4. The next one would be x squared, and then plus c. Notice that doing the substitution actually gives me the same thing this way. So as long as we do our substitutions, we can do them wherever we want, as long as our variables agree when we do the antiderivative. Okay, so we're going to do some substitution on this one also. So we're going to start, they actually will give you, for right now, what we should substitute into this. What we have is a more complicated function. I couldn't take the antiderivative of this as it is right now. But what we're going to do, we notice that inside of e we have a more complicated function, so they ask us instead to make that a u there. Now we're going to have to, since we have a dx here, we need this in terms of u, we need du. To find that du, we're going to use whatever we used for our substitution here. I made this cosine of x be what we're substituting here. Notice we still have the sine of x and this dx here. If I take the derivative of what I substituted for x, that's going to give me a negative sine of x. We're also going to tag on the end a dx. Okay, that's because we're telling us which variables are being whether we're taking the derivative of here. So du is actually equal to negative sine of x dx. Now looking back at what we had left here, we had the sine of x left, we had the d of x. We actually need to do that substitution for the whole thing. I do have an extra negative there, so the substitution I'm going to do is a negative du instead of sine of x dx. So the sine of x dx is gone. We're going to put in a negative du. The integral sign is still there, and this is equal to that because we did a substitution. We'll now take the antiderivative, keep the negative out front. Antiderivative e to the u is e to the u. It's a general antiderivative, so plus c. And since we started in terms of x, we should finish in terms of x. And so substitute whatever we had back in there. U is equal to cosine of x, and then plus our constant. Okay, for the next one, again, they're giving us something to do for our substitution. Notice the reason that they're doing that is this x squared plus x is inside of something squared, whereas this is kind of left by itself. Also, if you look closely here, because our next step here is going to be changing that du, when we take our derivative, that's going to give me 2x plus 1 dx. And notice that's what we have left right here. So if we're going to do a substitution on this, the only thing left right now is that 3. We'll just pull that out. This part here is what we substituted for u, so that's going to be u squared. So that's squared. And then all of this will be equal to our du. We can now take an antiderivative here fairly easily. U to the third would be u squared would be 1/3 u to the third plus a constant, and then that would simplify to u cubed plus c. We want this, since we started in terms of x, back in terms of x. So we'll plug in the x squared plus x again to the third power plus c. If we want to double check our work, then we could take a derivative of this using the chain rule. That would be 3 times whatever's inside, drop our power, and then multiply by the derivative of the inside. Notice this is what we started with. This is the correct solution to our indefinite integral. In this last example, we're asked to use the substitution u is equal to x squared. So we'll notice that would go right there, the sign of u. And I want to look again for my du by taking the derivative of this side, 2x, and then dx. Now if we look at what we have left here, after I do the substitution, I'm left with an x and a dx. So let's go ahead and group those together. And notice that I actually have more than that. I only want the x dx part of this. And so what I'm going to do is I'm going to move this 2 over the other side and make this 1/2 of du is equal to x dx. And now I can do a straight substitution here, where rather than x dx I'm going to use 1/2 du. And I can put the 1/2 really wherever I want to put it. So I'm going to put it out front. Now I take my antiderivative. I'm mostly concerned with the sign of u. Antiderivative sign would be negative cosine and then plus c. We want this back in terms of x, so I'm going to substitute the x back in, so negative 1/2 cosine, our substitution was x squared, and then plus c. And if we wanted to check our answer, we could do that by taking another derivative